Okay? So, this is part 2 of analysis of rectangular reinforced concrete beam, NSCP 2015. So, problem. Given the data of the concrete beam width is 300, effective depth is 500, concrete strength is FC prime 28 megapascal, steel yielding strength is 415 megapascal. The beam has two 25 mm bars at the compression side, having an effective cover of 65 mm. If solid bars are found necessary to resist the load, the effect of concrete displaced by solid reinforcement shall not be neglected. Use NCP 2015. First question. What is the design moment capacity of the beam in kilonewton if the tension steel AS is 628 mm placed in two layers with outmost layer placed under the depth of 530 mm? Second question, what's the stress in MPa in the two 25 mm bars if the tension steel AS 628 mm bars is placed in two layers with outmost layer placed under the depth of 530 mm? So this is the questions and the answer. So how do you solve it? Siguro illustrate din muna natin para madaling maintindihan. Sabi, we have a beam. Ang beam natin is walang total depth na sinabi pero may effective depth na sinabi. Diba? Our beam is 300 mm deep, wide, and meron daw tayong 6 na 28 mm. 1, 2, 3, 4, 5, 6. So that is 6 28 mm bars. Tapos sa taas doon meron tayong dalawang 25 mm bars. Okay? So we have a effective depth of 500. So saan yung effective depth na yan? Sa gitna, sa centroid. Center of gravity. Yung gitna na yan, okay. Yung gitna niyan, papunta rito, is 500. Okay? Sa situation natin, outmost layer daw is 530. So that is, what is this? D prime. Diba? So mula dito, papunta dito sa centroid na to. So that is 530. Okay? So, ano pa ba? Hindi natin nabibigay. Wala naman, meron na. So, this is the illustration. Now, if found necessary lang naman itong 25 mm, ang ano daw pala niya, ang effective cover niya is 65. So, etong part na to, hanggang dito sa gitna na to, is 65. Diba? So, that is D prime. This is D, yan. This is DT. This is D prime. Diba? So, okay. So, now, first thing is we check if doubly reinforced ba siya or singly reinforced lang. Diba? How? Using Romax. Again, maraming way para malaman yun. Pwede mong gamitin yung strain. Pero sa atin, para lang maging uniform yung natin, consistent yung solution natin, I'll be using the raw. Okay? So, we have raw. Kunin mo natin tong area ng mga bakal para hindi natin kukumpitin mamaya. 5/6 times 28 squared. So this is 1176 pi para mamaya madali natin susulat. Yan tayo mag-compute. Ito naman sa 25, dalawa lang siya. So that is 625 over 2 pi. In terms of pi ko siya para madali siya isulat mamaya. Kasi pag may decimal, nag-round up na tayo. Pag may pi, wala pa tayong nag-round up. Diba? Okay. So let's check. First, what is the design moment capacity of the beam? Ang tanong, what is MU? But first, we should know if it is a singly reinforced beam or a doubly reinforced beam. So, for us to know it, we solve for rho actual. Okay, rho actual. What is rho actual? It is AS over BD. We have AS na, which is 1176 pi over B, which is 300. Ang D natin, that is the effective depth. So, that is 500. Okay. So, what is the answer? 1176 pi over 300 times 500. So, that is 0.04, sorry, 2463. Okay? Next, tingnan natin yung limit state. Of course, hindi possible na ang labo naman niya sa rho minimum. Saka kung nasa rho minimum yan, gagamitin niya rho minimum. So, usually sa analysis, ang ginagamit na yung max. Diba? Check natin yung rho max ng tension controlled and yung rho max ng 0.004. Okay? Sa rho max ng tension controlled, we have 0.85 FC prime over Fy multiplied by beta 1 3 over 8 dt over d. Dito naman 0.85 FC prime over Fy beta 1 3 over 7 dt over d. Okay? Take note, in this case, dahil double layer na tayo, sinabi na double layer tayo, yung dt over d natin is not equal to 1 na. Okay? So, let's solve it. For example, for this problem, we have 0.85. FC prime is 28. All over. Fy is 415. Beta, since our FC prime is less than or equal to 28 megapascal, our beta is just 0.85. Okay? 3 over 8. Ang dt natin is 530 over d, which is 500. So, what is rho? Our rho would be 530 over 500. 0.013 1938. Okay. Dito naman sa rho max ng 0.004 ng strain over 7 lang papagtala natin 0.02215. Therefore, what can we say? We can say that rho actual natin or rho is ang rho natin is greater than rho max TC rho max 0.004 and also greater than rho max tension controlled. Therefore, this is DRB. Okay? So we should consider it or take this as DRB. So, para malaman natin yung moment, ano ba yung unang hinahad natin? Diba? We solve for A. Diba? How? So, in this case, we will be using CC plus CS is equal to T. Okay? So, ang CC natin, madali lang. 0.85 FC prime AB. Diba? Ang CS natin, that is just the still ng compression side. So, that is AS prime, FS prime. Pero, sabi doon, hindi natin pwedeng i-neglect yung concrete displace. So, mag-subtract tayo ng 0.85 FC prime. Para pag sinabi pwedeng i-neglect, tatanggalin mo lang yung 0.85 FC prime. Diba? Ang T natin is AS FY. Okay? Or FS. Okay? So, assume. Dito, mag-assume tayo. Assume all steel will yield. Assume lang yan, ha? Check natin mamaya. If all steel will yield, all FS will be equal to FY. Diba? So, gawin natin to. Solve for A tayo ngayon. 0.85 FC prime is 28. A is unknown. B is 300. Plus AS. Ang AS natin, AS prime is 625 over 2. 625 over 2 pi. Multiply by, ang FS prime natin, inassume nga natin na mag-yield lahat. Therefore, ang FS prime natin is 415 muna. Minus 0.85 FC prime, which is 28, equals to AS, which is 1176. Diba? 1176 pi. 76 pi. Ang FY natin is 415. Diba? 415. Okay? So, solving for A, will get what? 160.95 mm. Okay? Now, since na-solve na natin to, we have to check if nag-yield ba talaga lahat ng bakal. Diba? So first, let's solve for C muna. Ang C natin is just A over beta, where beta 1 is just 0.85. So 160.95 all over 0.85. Therefore, ang C natin would be 189.35. Okay? mm. Let's check. FS muna tayo. Dun sa tension, stress and tension steel. Formula is 600 multiplied by dt over C minus 1. Therefore, that is 600 multiplied by dt, which is 530, all over C. What is C? 189.35 minus 1. Therefore, ang FS natin is 600 times 530 over 189.35 minus 1. Therefore, 1,079.42. 43 na lang. Okay, 43. So, we could say that FS will yield, diba? Greater than FY. Therefore, tama tong FY natin na to. Okay? Now, ang check naman natin ngayon, kung tama, itong FS natin na to. FY ba talaga siya? Kasi ginamit natin siyang FY eh. Diba? In FY din natin siya eh. Tama ba? Yun ang tanong. So, let's check it here. Excuse me. So, let's check. Fs prime. What's the formula for Fs prime? That is 600 multiplied by 1 minus D prime over C. So, using this formula, 600, 1 minus 65, diba? Over 189.35. Correct me if I'm wrong. 65 nga ba? Effective cover is 65. So, D prime is 65. Okay. So, ang Fs prime natin would be 394.03. Therefore, Fs is not equal to Fy. Sabihin, mali to. Mali itong part natin na to. Diba? Mali assumption natin na ginamit dito eh. Sabihin, hindi natin pwedeng gamitin yun, kukuha natin value dito. Okay? Mali yung A natin na to. Okay? So, done. So, huwag niyong buburahin ng ganito to sa inyo. Pinakita ko lang sa inyo na paano pag hindi siya nag-yield na ganyan. Okay? So, now, since hindi siya nag-yield, you have to get pa rin yung A sa C. Paano? Paano pwede natin gawin? Gawin natin in terms of A natin siya gawin. So, let's solve it for, let's, in terms of A. So, okay. So, CC plus CS is equal to T. Now, hindi tayo mag-assume dito. Alam natin na yung Fs is equal to Fy, but Fs prime is not equal to Fy. Therefore, ang Fs prime natin, if in terms of A, ang mangyayari dyan, 600, magiging 1 minus D prime over ang C. Ano ang C? C is just A over beta, di ba? So, let's solve it. So, 0.85 FC prime. Ang beta na, ang A natin dyan is A. Ang B, yan, lagyan natin. Plus, AS prime. So, AS prime. Plus, multiply by FC prime. Ang FC prime natin dito, buuin natin siya. Ilagay mo. 600. 1 minus D prime over A over beta minus 0.85 FC prime equals to AS Fy, diba? Okay? So, our unknown lang dito is A, diba? We have B, we have AS prime, we have FC prime, we have AS, we have Fy. Alam na natin yan eh. So, solving that, gawin nating 0.85. FC prime is 28. A is unknown. B is 300. Plus AS is, AS prime is 625 over 5, over 2. Multiply by pi, multiply by 600, 1 minus D5, D prime, which is 65, over A, over beta, 0.85. Cos parenthesis minus 0.85, FC prime is 28, equals to AS, 1176 pi, multiply by Fy. Ito, alam na natin kasi na nag-yield siya, di ba? Kasi Fs prime natin hindi nag-yield. So, we have to put the formula of Fs. Then, makakakuha tayo dyan ng A. Diba? Kasi yun na lang unknown eh. Oh. Yun na lang unknown. Therefore, ano makukuha natin A? Makukuha natin A dyan is 163.4. Diba? So, 163.4. Pag dinivide natin yung 163.4 divided by 0.85, 192. Diba? Therefore, C is equal to A over beta. It was 192.24 mm. Diba? Okay. So, since alam na natin to, let's solve now yung Fs. Fs, pwede hindi natin i-check. Kasi alam natin na mag-yield na siya. Ang kailangan natin i-check ngayon is yung Fs prime. Diba? Ano yung Fs prime? 600 minus 1 multiplied by 1 minus 65 over A over beta C. Ano ba yung A over beta C? Over beta. Diba? That is just C. So, that is 192.24. So, the answer would be 397.13 megapascal. So, still, Fs, less than, ang Fs prime is less than Fy. Therefore, Fs prime will not yield. Diba? So, ano tong Fs prime natin na to? Ito yung stress na to. Nagkataon lang na nauna natin siya na-solve. So, that is the answer for number 2. Stress in 2 25 mm bars. Okay? Siya Fs prime. So, this is, the answer is 397.13. 397.13 megapascal. Diba? Nagkataon lang na nasolve natin siya dito. Okay? So, that's the answer for second question. Pero kasi, this is just a part of what we are going to find dun sa unang tanong. Kasi unang tanong, di ba, is the design moment capacity. So, since alam na natin to, ito kasing Fs prime na to, pinakuha lang sa atin to ngayon para malaman natin kung tama yung assumption natin na nag-yield ba yung bakal o hindi. Pero, unfortunately, sa unang assumption kasi natin, inassume natin lahat nag-yield. Diba? Pero hindi pala mag-yield yung Fs prime. So, inulit natin. Now, pagka-ulit natin ngayon, you have to check naman ngayon kung talaga bang ano na yung tunay na value ng Fs prime. Okay? So, since alam natin yung tunay na value ng Fs prime sa Fy, tama na ngayon yung magagamit natin na A saka C. Okay? So, we can now solve for Mn. Diba? Ang Mn natin, Mn, ano ang Mn natin? We can use the T1 plus T2 yung ganon. Pero pinakamaganda is, ang gamitin natin is yung C multiplied by D minus A over 2 plus CS multiplied by D minus D prime. Diba? Pag ginamit kasi natin T1 sa T2, kailangan pa natin hanapin yung AS2. So, mahirapan tayo. So, magaganda, gamitin natin itong ginamitan sa una, which is CC plus CS. Diba? So, CC. Ano formula ng CC? 0.85 FC prime. So, that is 28. Ang A natin is, ang gagamitin natin na A is this. So, ang A is 163.4. Ang B natin is 300. Diba? Ang D is 500 effective depth minus A. What is A? Yun ulit. 163.4 all over 2. Diba? Plus CS. Ano ba ang CS? That is AS prime plus FS prime, etc. Diba? So, in this case, alam na natin yung AS prime, 625 pi over 2 multiply by FS prime. Diba? So, ang FS prime natin is 397.13. Yan lang ba agad yun? FS prime lang. We should subtract yung concrete displaced. Diba sabi wag daw i-neglect. So, mag-subtract ka pa ng 0.85 FC prime 28. Okay? So, now we multiply it to the moment arm, which is 500 minus D. D minus D prime. So, D prime natin is 65. So, we'll get an Mn of what? We'll get an Mn of 647.4 kilonewton meter. Okay? So, is that the answer? No. Because the question is design moment capacity. So, that must be MU with factor. Diba? So, ang MU is just phi Mn. Question, what is phi? Go back to the sa part natin. we could see that FS natin, ang FS natin is 1,079. Eto, tama to. Diba? Why? Kasi, tama yung ginamit natin na assumption na yield yung bakal. But let's say solve din natin muna. Kung dito, doon lang natin na yield yung bakal sa tension side, kaya ang ginamit natin 413 kasi lumagpas na siya ng 415, nag-yield yung bakal. So let's say, kung nga rin hindi natin alam kung nag-yield ba talagang bakal, solve ko na rin yung Fs prime. Fs pala, 600 dt over C minus 1. The answer is what? So, let's say muna na hindi natin alam. dt is 530 over 192.24 minus 1. So, the answer is 1,054.18. So, this is the actual Fs. But still, nag-yield pa rin siya. Diba? So, kung nag-yield siya, ano naman siya? Transition o tension controlled? Since this is greater than 1,000, therefore, this is tension control. Diba? Therefore, our phi would be 0.9 times mu 647.4. So, that would give us to 647.4. That would give us 582.66 kilonewton meter. So this is the answer. Okay? So etong pagkuha ng Fs na to, pwede hindi natin siya kunin dahil hindi naman siya tinatanong eh, 'di ba? We just have to know kung nag-yield ba talaga siya o hindi. Okay? In this case kasi tinatanong yung Fs prime. Kaya sinolve pa natin Fs prime. Pero ganun pa man, mali kasi assumption natin dito sa una. Kaya pinahanap din sa atin ngayon. Kung hindi man tinanong yung Fs prime dito sa question, you have to check din yung Fs prime. Bakit? Kasi nag-assume ka. Dapat, magkaroon ka din ng proving. I-prove mo kung nag-yield ba siya o hindi. Diba? So, that's it. So, this is the moment. So, 582.66. So, the answer for question number 1 is 582.66 kilonewton meter. Yun lang. So, tandaan, laging alamin mo lang kung doubly reinforced o singly. Then, you get for A or C. Diba? True what? C is equal to T. CC plus CS is equal to T. Yun lang naman. Then, after that, makuha mo na A saka C. Diba? Check mo kung nag-yield o hindi. Ganun, para ma-sure ka. Then, since alam mo na yung A saka C, makakasolve ka na ng MU or MN na moment, di ba? After getting the moment, you applied the reduction factor. Okay? So, that's it. I hope you learned something from this video and see you to the next video. Thank you.